Hello and welcome everyone. My name is Michael Sullivan. I'm VP Sales at SimActive, and I'm excited to kick off today's session, Photogrammetric Accuracy Requirements, How to Meet Them. So today's topic is one of the most important and misunderstood areas of photogrammetry. Accuracy is at the heart of every deliverable, whether you're mapping for engineering, for surveying, infrastructure planning, utilities, or environmental projects. And I'm joined by someone who some of you listeners are familiar with. He spends most of his time helping clients troubleshoot these exact challenges and improve their workflows. David Alamillo, photogrammetry specialist here at SimActive. David, great to have you. Before we jump in, can you introduce yourself and share a bit about your work here at SimActive?
Sure. Thank you, Michael. And again, thank you for having me here. It's a pleasure. Yes, my role really involves collaborating, with clients all over the US, Canada, Latin America. We try to always deliver a comprehensive view of Correlator 3D, as well as always assisting them through the sales process, all the way down to implementing a workflow that is effective, that is optimized to their needs. And one of those things, of course, one of the needs to check is accuracy. So I'll always cover this topic even during the early meetings that we have with them, all the way down to a project that we process for them during, our demonstration of the Correlator 3D. And obviously showing them tips and tricks. There are always tips and tricks to this. I always find that accuracy is one of those things that is sometimes inherent in the data, but there's certain things, tips and tricks you can do to enhance it or even make it more evident, when you're processing the entire project, the entire solution. So yeah, it's a great topic. We're really happy to be covering this with you today.
Awesome. Excellent. Thank you, David. So before we dive in, a few quick housekeeping notes. If you haven't already, make sure you subscribe to the SimActive newsletter. We share updates, case studies, and invitation for future webinars like this one. You can drop also any questions in the QA box at any time during the webinar. What we do is someone from our team will reach out after the webinar and provide an answer to you. And then finally, make sure you stick around for a live demo of Correlator 3D, where we'll have David here speaking with us right now, who will show you how to apply the accuracy workflows we're discussing today in real-world examples. All right, so let's get started. Today, we are focusing on how to reliably achieve photogrammetric accuracy from acquisition to final validation. So here's what we'll cover. We'll go over understanding the value of RTK and PPK, using GCPs versus checkpoints, one or the other, or both, or not at all, actually. Leveraging lidar as a control layer, and finally, ensuring final quality and validation. And David, of course, will be coming back to your hands-on experiences with clients throughout the session, like you just explained throughout your roles. So let's begin. RTK and PPK. I feel like these are two terms that get thrown around a lot, in our industry, sometimes without clarity. So in modern photogrammetry, precise positioning is often the foundation of accuracy, right? And high quality GNSS and IMU data helps reduce reliance on dense ground control points. It helps improve the AT consistency, aerial triangulation, and it helps speed up production. So David, from your experience, perhaps we can start actually with what is RTK and PPK. Can you explain that to us in simple terms?
Sure. And most folks who buy their first drone are not familiar with this term, and I've referenced more to the drone systems because that's where you see it, right? The most often, RTK specifically, which stands for real-time kinematics. Sure. And lane terms, and I know we've covered this in previous webinars, but it's basically the corrections that are applied to the images while you're up in the air, right? So you're basically providing a solution that is accurate by the time the drone is capturing all these images up in the sky. Of course, there's a base station that is tied to it. There are corrections that are being applied real time, as the name states.
Sure.
And the counterpart to that, which we've seen a lot on other systems that are not necessarily drone systems, but it's PPK, which of course applies to drones also, right? There are PPK corrections done to drone systems as well as manned aircrafts and higher systems in the ranks, right? Which is post. So when in one side you have the real-time kinematics, and the other one you have the post-processing kinematics. So you do one in real time, you do the other one in post when you're in the office. Each one really has their own benefits, right? Each one has their own advantages. When you're up in the field and you're getting the real time and you're basically don't have to take that extra step to do the post-processing, it's great. But things happen in the field. And I think we'll talk about these things that could happen in the field, but these are basically the two definitions of RTK and PPK. Laying simple terms. If you bought your drone and you're like, hey, this thing says it has RTK, and then how do you turn it on? Well, sometimes it goes more than just flipping a switch. There are a lot of things you need to check, but yeah, this is a great topic. So I think, yeah, lane terms, that's really the differences of RTK, PPK.
Very good. That's crystal clear, David. Thank you very much. So
sure.
Perhaps the next question or the next topic would be, I mean, where does it make a difference really? Why do people want to use RTK and PPK? What are the benefits? What are the pros of using them?
Sure, that goes tied really with a word called high absolute accuracy, right? When we're talking about absolute accuracy, that's when RTK or PPK come into the conversation. So that's hitting the topic right on. But the next thing that it's tied to it, and I hear it the most, is fewer GCPs, sure, or no GCPs.
Sure.
So that's where we start introducing probably the controversy, because a lot of folks, I say fewer GCPs. That's my standpoint on it, right?
Sure.
Because there's no system that can be flawless. But so I would say the biggest difference is made really when you want high absolute accuracy with fewer GCPs, because it really, the trajectory of the drone, like I said, it's stabilized, right? So you have a nice stabilized AT as well. You reduce distortions, and the one that I mentioned early on, you speed up production.
Right.
Now, is it flawless? No, absolutely not. Like nothing, like everything in the world, there's always things that you need to keep in mind. So I would say key points really go into strong absolute positioning early on, really early on the workflow. Fewer GCPs.
Sure.
I would always say fewer GCPs. You can't take away the GCP component. It will give you better geometric stability for sure. Sure. And I would say in that topic, there's certain things you need to check for. So we can cover these either right now or, we can cover them later. But I would have like a 3 list of things that I would cover of watch out when you're doing RTK, because, yeah, they'll definitely come bite you if you don't check them.
Sure. Very good. So perhaps we can touch on these points at the end. Sure. But that makes a lot of sense what you're saying. So in essence, RTK, PPK can be very powerful if used correctly. And I would say it's fair to say there is a small learning curve to using RTK and PPK. Would you say that's a fair statement to say?
Yeah, absolutely. And the environment plays a big role here in the entire data capture as well. So one is the knowledge, and second of all is, when and how to capture it and validating that. Yeah, absolutely.
Sure. Very good. So maybe another question or two I have on that section would be what users should watch out for, and perhaps that'll touch a little bit to what you want to say at the end as well, and then we can recap at that point. But typically with RTK PPK, we hear a lot about poor baselines. What is that? How can that have an impact? Can you touch a little bit on that?
Sure, absolutely. And that really goes into that topic, right? Sure. Poor PDOP. That's the number one thing. And I had a chance to fly RTK systems back in the day, and that was one of the things that I was like, what in the world is PDOP? When I first read the manual, so, what does this represent? And I was looking at satellite geometry. I think that really ties into what PDOP is, which I remember correctly, that's position dilution of precision. That's PDOP for the folks
Sure.
out there, the nerds out there listening, which in essence just represents the overall quality of the 3D position. You know, when you're talking about latitude, longitude, altitude. So I thought, well, a higher PDOP is great. That's what I want to have. And that's completely wrong. The lower the PDOP, the better accuracy you have. That's how it works. And then you get into terms like HDOP, you know, which is basically just positioning your horizontal, so latitude and longitude. It really ignores the vertical, which I find it that always the vertical suffers a bit more in these type of cases. So yes, when you get baselines, you know, large baselines, I would say uh, they're sometimes over 10 kilometers, more than 10 kilometers. It really affects the solution, right? I would say other things that I like to watch out for would be reflective surfaces. You know,
Sure.
this is something that I learned the hard way, Michael, because I was flying a couple of solar panels with RTK. This was way back in the day. And I've had, well, folks reach out to me as well where they say they lost the signal completely in certain sites where there were heavy solar panels. And I discovered that the reflective surfaces really affected the RTK. So
Okay.
there was a loss of signal. When you landed and you checked your reports, like, what happened? I mean, the signal was pretty strong in other areas. Terrain was completely flat because there's solar panels not up in the mountains. The signals from the satellites were great. So reflective surfaces can corrupt the GNSS position. That's something I said I learned the hard way, and I've seen it over and over with RTK solutions for solar panels. Interestingly, you know, flat terrains.
Yeah, fair
So I would
enough.
say these things in general have been one of the things that I've discovered over the years, painfully or through other people's pain. This thing didn't work.
Learn through the process, right? Baptism by fire. So,
Absolutely.
out of curiosity, David, what drone system was that, and what year was that approximately?
Oof. This was actually back 5 years ago. That
Okay.
was about 5 years ago. A DJI Phantom 4 RTK. Yeah, I was one of the first ones I think that got to test at our previous company, you know, that
Sure.
drone. And they said, David, here you go fly that thing out in the sky and see what it does. Apparently we get sub-centimeter accuracy.
Sure.
So that's how it was sold to me. And maybe that's a good point. What is, you know, the minimum level of GNSS quality, you know, that customers should aim for?
Sure.
Because when folks are trying to sell you the systems, they usually go in like, you will achieve sub-centimeter accuracy with this drone. You go out in the field really thinking you will. And, you know, anyone who has been in photogrammetry for years or have gone through this process can understand that that's not real, right? The
Right.
sticker should say 3 to 5 centimeter RMS. You know, vertical goes higher sometimes from 2 to 5, 5 to 7, and that's good. You know, when you get a 1 to 3 centimeter vertical accuracy, I mean that's great, but there are a lot of factors that have to play into that specifically. If that makes sense.
For sure. For sure.
Yeah.
It's spec sheet versus real world, application. Yeah, very good. So I think we've covered most of the questions I had for that section. Let's go to the next topic. So one that is very important, if not more important, actually. So using GCPs versus checkpoints, one or the other, or both, or
Yeah.
none of them, actually. So ground control points and checkpoints are, often misunderstood. Many users depend heavily on GCPs, but these can mask accuracy issues and may even introduce new ones in some cases. So the key to understanding when to use GCPs, how many you truly need, and why checkpoints are essential for validation, we'll discuss that right now. So, David, can you walk us through first through the differences between ground control points and checkpoints, and how to use them both effectively?
Sure, sure. That's an awesome question. And under the premise that we kind of agree, you need GCPs. You know,
Right.
there needs to be some validation. So I would say that GCPs influence your adjustment, right? And the checkpoints validate it. I hope that makes sense. Try to make it as simple as
Yes.
possible.
Yeah,
So
yeah.
You always need independent checkpoints. They're sometimes people say, "Wow, they're exactly the same thing." Well, no, they're not, because your GCPs will influence your entire solution, whereas a checkpoint just validating that solution, right? Because they have no inference in the solution itself. So I guess GCPs are really essential when GNSS quality is weak. Like I said, in those cases for the solar panel example, I had GCPs in there because it was a solar panel installation field. So the survey team was kind enough to say, don't worry about it. We have some GCPs that we collected when we were actually installing the solar panels. So I was able to bring those in and use them. Why? Because my GNSS quality was completely weak. I mean, it didn't even work. Other thing I would say, survey teams, right? When you have to adhere to a strict survey and engineering specs, you always want to have your GCPs there. And the engineering team sometimes provide those to you. They're like, hey, here you go. I don't know if you're going to use them, but here you go. I would say use them. It's always important. And then we get into the topic of how to effectively use them. How many? This is the $1 million question, right?
Sure.
You probably got these over the years too, Michael. I mean, you've done hardware, and you've flown some great drones as well. How do you know how many? It's always like, well, it comes down to the site, right?
Of course.
I always used to ask for a KML of the site just to see how big the site is and potentially how well you can distribute them. And you'll laugh on this one, but I use this reference in our previous demo, and I tell them that when I explain GCPs, at least just a quick note, my kids always help me tag GCPs. So
nice.
I have my kids in projects be like, hey, help me tag these 20 GCPs. And they try to do the best they can, to center it. But to be honest with you, they used to tell me, how do you distribute these? And I explained to them, it's like making your bed. In essence, you want to have a nice distribution, corners, center, and then elevation extremes.
Sure.
That's over the years, that's how simple I've tried to make this or explain this and how to set up your GCPs. Of course, surveyors here on the call are going to start laughing because there's more technical components to that. But for someone starting, that's a good way of seeing it.
Sure.
Making your bed. You don't want to stretch more on one side and have it loose on the other. You don't want to have like a huge concentration of GCPs on one end and then basically have none at a certain point where you have extreme elevation changes. So I would say it's ideal distribution,
Sure.
corner, center, and then obviously looking at elevation extremes. That's how I would
Sure.
actually.
That makes a lot of sense, David. I feel like, in most cases, obviously, the ideal scenario is, in fact, you are working with a survey team and you have, a licensed surveyor, and they probably know, right, how to dispatch the GCPs. They know the terrain. They know where they should put control, where they should put checks, et cetera, et cetera. In some cases, of course, we have other scenarios where we have the pilot who needs to, take a bit of that responsibility, place the targets themselves, perhaps have someone shoot the targets. And in that case, I feel like the rules that you just shared are very applicable and is a good rule of thumb, right? Indeed, it's the $1 million question. We always get that question. How many GCPs should we place in a specific project? And the answer is very often the same. It's about how well it's distributed over your area, not so much about the number of GCPs, right? So
yes, makes sense.
Very good. So perhaps another question would be, and we just touched on it a little bit, but what are the most common mistakes that people make when dealing with GCPs? I feel like something can be said about the markers themselves that are being used.
Yeah, excellent. I was actually processing not too long ago a project where and to be fair, we sometimes are the photogrammetrists at these large companies where there's a pilot, there's a survey team, and the poor photogrammetrist back in the office gets all this data, and you're like, well, what do I do? Where do I start? Which is our GCPs, which are our checkpoints. And the number one thing I check, Michael, is projection.
Sure.
Because in what projection were they collected and what projection I'm actually processing my data, right? What the team could say, I want this in this specific projection, but my GCPs are in a totally different projection. So you always want to match that projection from your GCPs because, of course, you want to display them on the map when you're tagging. So that's important. I always try to, that's the first thing I do every time I receive a project is checking the projection on my GCPs. Common mistake is they're in a totally different projection.
Yeah, that's a good
Number
point.
two,
I think it's fair to say you'd be surprised, how I mean, how often this happens actually, right? Would you say so?
wow, a lot.
Yeah.
And the second thing tied to that, we're talking about RTK, right? When doing RTK, sometimes, well, of course, you're not going to use those GCPs as GCPs because you don't want to, adjust your block or the RTK correction that has been done. So you import them as checkpoints, but they might have a geoid applied. So when they were
Right.
collected, they had a geoid applied. And when you're running your bundle adjustment, and you're seeing your reports, you're consistently, let's say, 20 meters off. And immediately you can spot it because you can see that all your checks, at least vertically, they're 20 feet off or 20 meters off, whatever the metric might be. So you're like, a geode was applied. So you reach out to the team and go, hey guys, what geode did you guys apply to these? Oh, we applied so-and-so. Great. You restart Correlator 3D project, select the appropriate geode. When you're running your bundle adjustment, you see everything lines up now. So there are a few checks, I feel like companies, they're great. Sometimes they're providing all the information to the photogrammetrists, back in the office. Sometimes that lack of information can cause errors. So that's one that I think we back at the office processing data should be more strict about. What projection is it? Do they have a geoid applied? And then you mentioned it was the GCPs themselves.
Right.
Sometimes they're just soft targets. It's
Right.
something that it's moving in the field or that we got pushed by a truck, can't even see, Actually, we did an exercise on LinkedIn. And this was a great exercise because we put like 4 images there and we did like a poll. Like out of the 4, which one do you guys think is the best GCP?
Sure.
And we had like 4 examples in there. I hope we can find the LinkedIn post and I'll make a comment on that LinkedIn post because I really liked it. And
Sure.
I picked the one that had a little number on the GCP. And
Right.
there were other more like fancy ones, like the ones they sell that you basically just toss out there. They're amazing. I'm not going to say the name or the brand, but they're
Right.
great. They're great. But obviously when you have your little standard poor man's GCP, but you have a little number attached to it and you get a GCP list, you're like, oh yeah, that's GCP number 20. 20's right there because you can see the 20 written on the GCP on the floor. That makes our life so much easier, Michael.
I can imagine.
It's amazing.
It prevents you or the operator from going back or switching between files or attachments to fall back on your feet. So yeah, anything that makes the operator win time obviously is a good benefit. That's excellent, David. Thank you. These are really 2 solid points. So
yeah,
let's move on to lidar and discuss lidar a little bit. This is a topic that has grown quickly in the last few years, using lidar in fact as a supplemental control layer. So when lidar, and I think we've touched on lidar in past webinars quite a bit, so I won't go into details explaining what lidar is, but when lidar comes from a high quality system with a strong trajectory solution, it can provide in fact an excellent geometric reference, especially for that vertical component, which we just discussed a little bit previously. And that can be quite helpful for complex projects that include, forests, vegetation. I feel like vegetation is a word that comes back often with lidar. Road corridors, complex structures, and significant elevation changes within a given project. So, David, how do you see? And I feel like this ties, really well into some of the solutions that we offer. But how do you see lidar supporting traditional control, or in fact, I mean, I'm going with a bold statement here, but potentially even replacing? I'll let you expand on that.
Sure. Yeah, no, that's something that it's been picking up over the last couple of years, right? And we offer an excellent solution to incorporate those LAS, LEZ files into your solution. And the number one thing, and I'll go back to placement, GCPs, traditional GCPs, because usually you fly RTK over these type of scenarios where, dense vegetation you mentioned. If you're in the middle of the jungle, I remember I was talking to a customer up in Brazil, and he was saying, like, for me, it's impossible to go in the jungle and place a GCP because, a lion might eat me or a tiger might attack me. But on top of that, how do you see it when there's canopies covering the GCPs? So what they defaulted is lidar. So they introduced lidar to the system, and they said, we're going to replace this because obviously lidar will act as a dense control layer in essence, right? It's extremely useful when ground is hard to see in the imagery. That's I think in this scenario that was the number one thing of why they decided to use it, and vertical accuracy for them was needed. So it was something that they couldn't compromise. So what it did for them specifically, it really helped them validate, the photogrammetric surface accuracy. They imported, of course, the LAS file. They had some issues because the system, obviously dense forestry, lack of satellites, some issues in the RTK. So obviously that was pretty evident the moment they started adjusting their block and creating their own GCPs with the lidar data. One thing I remember that I've seen, sometimes using it for weak tie point generation as well. When there's like really, really weak tie points in the solution, lidar generates your surface perfectly. Of course, you're not relying on a DSM generated from images, so it really helps a lot. And the other component that we're talking about accuracy is exactly that, validating your accuracy, right? Because in this, you're adhering to the lidar accuracy that you have as you're extracting GCPs or using it as a reference ortho. So those are pretty much the big advantages that I've seen. In some cases, it has replaced GCPs out in the field. Not because they desired to do it, but it was basically a need. There was no way to place GCPs out, in heavy dense canopy. So I think these are the scenarios where, yeah, lidar is extremely helpful. And one thing that I like, you mentioned quality lidar data, right? Now more and more we see counties, especially down here in the US, collecting quality lidar data. Actually, in the county where I live, I know the surveyor, and he was tasked with collecting a big portion of the east side of where we live with lidar, and publicly available. I downloaded the lidar data, reviewed it. I mean, it's very good and accurate lidar data that it's publicly available, free for anyone who wants to use it. So we see this more and more. So I think it's going to be even more relevant in the upcoming years, right? Never replacing the surveyor. I will never say that, but I would say that it's a great tool when you don't have it, or in these scenarios where there's no way to place a GCP out in the field, or get eaten by a tiger. Use a lidar. Use a lidar.
No, but absolutely, that's a good point, David. Actually, what you just shared about the counties that make lidar data readily available, I feel like not a lot of people are necessarily aware of that you can just pull that data directly and use it in your workflow. And indeed, for some cases where your project is in a complex environment, I mean, this can be a lifesaver, right?
Absolutely.
In terms of control, but also, and we have discussed this over past webinars, discussing Correlator 3D and SimActive, but since you can use the lidar data directly and derive a DSM directly, you gain from the lidar data by itself, but also you gain time, right? Because you don't necessarily have to generate the DSM from the imagery, which typically, I think it's fair to say, is a relatively time-consuming portion of the full photogrammetric workflow. And so, in essence, there's multiple, pros from lidar that you can use in Correlator 3D. So, yeah, that's an excellent point. Thank you for sharing that. So,
absolutely, yes,
very good. So, moving on to, we've discussed all of this. So, RTK, PTK, GCPs and checkpoints, and lidar. And I feel like, obviously, the last topic we need to discuss on is ensuring final quality. So ultimately, the accuracy comes down to one thing and one thing only, right? Validation. You can have the best equipment, the best GNSS, the best IMU, great control, great processing, but unless you validate with independent data, you don't know your true accuracy ultimately. So validation typically includes RMSE and statistical reports, cross-checking trajectories, the aerial triangulation, surface model, visual checks as well,
Yes.
examining residuals and outliers, and documenting, all of this. So, David, can you touch upon how do you recommend users approach final QA and validation in a photogrammetric project?
Sure. No, you covered it perfectly, Michael. Yeah, validation really is everything, right? At the end of the day, it doesn't matter if your project is for an engineering firm or for just a small county. You have to go through the same rigorous steps of validating that data before it's delivered. And I pride myself in that we work with a lot of clients that are one of the most professional clients I've seen in the industry, Michael. And I really, that goes along with them being very, I would say, very specific on their questions.
Sure.
And that gives me a sense of pride because people who use correlated 3D are people who are dedicated professional users who provide professional results, right? So that topic is always on top of us, right? Is Correlator providing the most accurate data that we can obtain? Yes. How can you prove it? And we go into, mention it, independent checkpoints. The fact, and one tool that I love about Correlator is that you can always update those GCPs to checkpoints on the fly. Sure. You don't have to re-import them. You don't have to redo like the whole block or adjustment. You can simply go into the exact GCP and change it from GCP to checkpoints. So there's always no excuse of, having independent checkpoints. You can always use an existing GCP as an independent checkpoint in the solution. I would say that we provide one of the most comprehensive AT reports in the industry. Most folks stick with the quality report, and it's amazing, right? Because the quality report summarizes a lot of the project itself, but I believe that most folks are missing, the I guess the ins of the project itself, like the guts of the project. If you go to your IEO folder, within your Correlator 3D project, you go to IEO. You will find a section in the IEO for every step you run, starting from your type point extraction all the way to your bundle adjustment. And you'll see there's an AT summary report. It's a TXT file, so it's not the typical fancy PDF, but we make those on purpose because we want you guys to be able to edit or copy them fairly easily if you need to incorporate this into a more professional report. Some folks have their own reports that they actually deliver with the company logos, and we make this easy for them to just copy paste these elements of the AT. So what will you find there? RMSE reports, AT residual. One other thing that I like to highlight, obviously type point distribution, type point residuals individually as TXT reports. Amazing. But you can also do surface comparisons. And I've been showcasing this in the past 2 webinars because a lot of folks are not aware that they can actually, once a DSM is created, you can actually run a comparison or run a quality check against your surface and your control or checkpoints. Sure. And actually see if that surface is actually adhering to the standards that you need. So this is something that a lot of folks, and I'll cover it in our demo so you guys can see it again. But I can't thank Correlator 3D for making this so simple, right? Because you don't have to go through an external software to validate this type of information. You could do it within Correlator. So I was saying those 2 areas, along with your handy dandy quality report, are one of the main things you need to look out for validating and doing your QA/QC of your accuracy checks, right? Then the final one I'll probably say is, and this is the most simple one, I did it in our previous webinar as well, is physically going to your mosaic and validating that the GCP is actually where it's supposed to be, right? Right. It's a simple check. Anyone can do it. It's extremely easy. You don't have to really know too much about photogrammetry, but if you know that point is where the target is, well, it's somewhat accurate. So
absolutely, it gives the sanity, right? That you have like a pretty good deliverable on top of the metrics that you have, right? Of course.
Exactly.
Yes. Very good. So just to summarize briefly, but essentially, and I feel like we say this a lot internally at SimActive, right? But You just mentioned the QA report from the aerial triangulation has a lot of details and metrics. In essence, typically when you have a good aerial triangulation, the rest of the workflow flows rather easily, right? And you can generate results that will be reliable, that you, of course, will still need to check, like you just described. But I still
Yes.
feel like the nerve of the game is the aerial triangulation, right? Would you say that that's fair to say?
Yes, yes, absolutely. And this goes to another suggestion we always make. Large projects, right? You're processing a 10,000, 15,000 project imagery. Um, we always recommend doing the AT on all those 15,000 images.
Sure.
You know, why? Because you adjust the entire block. And what that ensures you is the next steps can be broken down in batches, right? And which is obviously what I recommend. And going back to quality checks and accuracy, some folks say, hey, I want to run my DSM in one single run of 20,000 images. The problem is when you're doing QA/QC, you have to do QA/QC on a DSM that it's huge for over 20,000 images. So what I recommend is run your AT over those 20,000 images, but break down your DSM, your orthos, and mosaics into smaller tiles. That will ensure you actually paying attention to the QA/QC process for each section. And if you have to redo a section, you're not obviously taking a million years to rerun the entire DSM. So I think that goes hand in hand, like you said, a good accuracy block. The foundation of your project is your AT. So do it on all your images, right? Do it in one single stride. But when you're breaking down the rest of the products, that's the easy part where you can actually do a nice QA/QC, but at the same time, break it down in stages so you have enough time to review the results and make sure you're making some good progress. That's an excellent question, Michael.
Of course. Thank you, David. Yeah, that's a very,
Yes.
very good answer as well. I think, I'm keeping an eye on the time, so I just want to wrap up as we're nearing the end. David, you've supported hundreds of customers, throughout the years, from small survey firms to national mapping agencies, basically. Can you, one final question? What are the biggest mistakes you see users make when aiming for high accuracy? Can you perhaps just briefly summarize, what we just discussed? I feel like that falls into that question, essentially.
Yes, I think the biggest mistake is assuming good accuracy
Right.
instead of proving it.
Right.
That for me is the biggest mistake. I love the automated workflow. Don't get me wrong. I love it. It's amazing. But when you're using your automated workflow, you're assuming your project is going to be excellent. In some cases, you can because you've done this so many times. It's a repeatable project. But I always advise the folks when we're doing our first initial calls with them or we're doing training, the AT portion, we have the benefit the correlator is a modular solution. So take advantage of that. The AT can be done manually. You can pay 100% attention to the AT portion of your project, and then the rest can be done automated workflow. You can automate the rest of the process. But the AT, don't assume that you have good accuracy. Prove you have good accuracy. Sometimes flying with weak GNSS, poor GCP distribution. Maybe another one that I'll add to that, talking about port, is GCP clustering. When we get those GCPs and checkpoints, sometimes since we don't know which ones are checks, which ones are GCPs, we have two GCPs right next to each other and we still keep them in there. So we cluster the solution with GCPs. That's another big mistake I see, And then you find out, I was like, oh no, this wasn't a GCP, it was a checkpoint. They're extremely close to each other. So there should be no image GCP clustering. That's one that I would say double check. And yeah, I guess the number one success factor is high quality trajectory data.
Of course.
Plus independent validation. I think that would be one of the things that I'll say as a final comment on that.
Yeah, that's very good, David. I think we'll use this as a conclusion. In fact, since we're nearing the end of our conversation today, so big thank you. Obviously, we work together
Yes.
every day of the week, but it's a pleasure to be doing this exercise with you as well, of discussing what our customers interact and your knowledge, because you really truly do see thousands of data sets ultimately end up on your desk. So you really do have knowledge to share. So thank you for sharing your expertise today. Thank
No,
you,
my
David.
pleasure, Michael. My
Awesome.
pleasure.
Awesome. I'll finish with a few final notes. So if you enjoyed this session, make sure you subscribe to the SimActive newsletter for the upcoming webinars and case studies. And now, of course, I'll hand it over to no one else than David to do the live demo. So he'll walk you through, the actual accuracy workflow in Correlator 3D. So it's something to look forward to. Make sure you stay on until the end. Thank you again, everyone, for joining us. Thank you, David, again.
My
And
pleasure.
yeah, we hope to see you at the next webinar. Thank you.
See
Have a
you in
good
the
day.
next one.
Great, guys. Well, let's continue with our demo portion of our webinar. And let's take a look at this data set. We received a set of images that were RTK corrected, and at least that's what we were told. And then through the processing, we discovered we had a couple of issues with this data set. So let's take a quick look, a recap of what we did, and where we found out that these weren't really RTK corrected. So let's go ahead and open up Correlator 3D. We'll go and open our project, and which today I've labeled non-RTK. Great set of images. Again, we didn't have any control for it. We didn't have any checkpoints, so we basically didn't have much to go with. But we did know, and well, what was told to us was this was an RTK flight, so that's how we needed to process it. So the first things first, we load up our imagery. We review, basically our images, make sure we're in the right location. Remember, guys, that's kind of a sanity check we do. We right-click any of these images just to make sure we're actually on the right spot. And then, obviously, once we confirm that, we have the satellite image background there to give us a quick overview that we're actually in the right spot. We confirmed the projection, which was super easy. It was UTM, so nothing specific. So we had that part confirmed. So no geoid applied, so they were like, okay, just process the data, RTK, PBK, pretty simple. Now what we're going to do as a first step, of course, with every single process is go to our aerial triangulation. The software will prompt us to do our type point extraction. So let's take a look at that. I always like to remind folks how the type point extraction looks. So very good type point extraction. You can see immediately, you actually see there's a good spider webs going on between all those images. That's what we want to see. A lot of folks always like to switch over the view from this IEO disks to actually kappas. So you can always switch in between the views, right? I guess and for some folks it's easier to view them as disks, because when you get this disk view, you actually see all your images here in red, which denote just a pixel residual, right? So we have the bar here, and it's completely normal to see all these images in red with a high residual after the type point extraction. I've seen, of course, in some cases with metric sensors, you actually start seeing very low residuals even after the type point extraction. But again, we're talking about true metric sensors with a calibration file. So in this case, completely normal to see everything in red. Actually, the one you don't want to see are images in blue. This is where you would see a blue disk there. That means that that image does not have a type point. And what would we do in those cases? Well, very simple. We have the option through Correlator 3D to add a manual type point through the link creation tool. On top of that, and I'll make this comment because a lot of folks have questions regarding this. What about if I don't have, well, if there are a lot of type points in there that are missing because it's dense forestry, and I already did exhaustive, so that's another key component here. If you already did exhaustive extraction and you see a couple of images with no type points, the next question is it RTK PBK corrected? And a lot of folks doing, of course, dense forestry opt to do RTK or PBK corrections because they don't have the ability to add a GCP in the field, right, as we were talking during our webinar. So can you proceed with your solution with no type points, with images with no type points when they're RTK corrected? The answer is yes. You can still proceed with them, as we won't adjust XYZ. You only address the orientations, the attitude, so we don't do any corrections to the XYZ position of the image. So you are able to move forward. And that is a great advantage, right? Because in dense forestry, you don't want to take, an hour, 2 hours doing manual tie points. So you can proceed with that. So I'm happy we're recording this for all those folks who have that question. That's a very common one. But this is a case where this is quote unquote RTK PPK corrected, and we have a nice tie point coverage, so we don't need to do manual tie points. So what is the next step in the workflow? Very simple. We will go to our bundle adjustment tool, and of course we're going to adjust our EO adjustment to RTK PPK assisted. Sensor calibration, this is not a metric sensor, so we're going to default to unconstrained. No ground control points yet. I didn't have any ground control points for this project, and no image filtering. I don't want to filter anything, so we process. Now, what was the result? Well, to my surprise, let's look at the quality report. Poor quality assessment. Very high average projection error, over 8 pixels. The standard deviation is close to 5. Of course, my tie points look very good, but as you can see, we're doing RTK, XYZ are fixed. And I was reviewing the solution, and I was reviewing if in fact this was actually RTK corrected. So I reached out to the team that provided this data set, and I told them, you know what, guys, I've looked at the data, and first of all, there's no reports to it being RTK. I don't have any other reports in the folder. On top of that, could you guys please confirm it? Because even on the geotags and the EXIF, I don't see a tag saying it is. I was actually pretty surprised when they said we made a mistake, because this is a very precise firm. So like, we made a mistake. These images were never corrected. This was the first flight we did with RTK wasn't available, so they're not RTK. But guess what? We do have a couple of checkpoints. They're not the best. Maybe at the edges of the project, can you still use them? I said, shoot them over. And what projection are they? UTM, perfect, same projection. So let's incorporate those GCPs. So what we did is, we can close out of this. We can even delete our step. Go ahead and delete that subsequent step, and start our bundle adjustment fresh. Now, do we need to redo our tie points? No, tie points are there. We don't need to redo our tie points. And as the GCPs are in the same projection, the only thing we need to do is go to the top right-hand corner, import a GCP file, browse for a GCP file, and just browse for a GCP. So we have a GCP file here, a TXT file, open it, and then I believe these are semicolon. Yep, import all our points, XYZ or long lats. If you're using longitude, latitude, you can always switch to geographic as well. So that's an option, and import them as GCPs or checkpoints. So there's no purpose of importing these as checkpoints, because they're not going to validate anything in the RTK, because this is not RTK corrected. So what we're going to do is switch them over as GCPs and add them as GCPs and import. Once we do that, we have our GCPs loaded into the solution. Like I said, they said they're not the best GCPs, but we'll go through the motion of tagging the GCPs. Let's just open up here our tags, and we'll go and again go through our GCP motion and tag our GCPs. Again, they had to provide like kind of a cheat sheet of exactly what they tagged, but they had some tags, so it was fine. I was able to get like some ground pictures of exactly what they tagged. So that made the process really, really simple. Again, trying to rescue this project, right? So what we're going to do now is run our bundle adjustment. Like I said, we can delete the previous RTK run, or we can leave it. I left it in there, but again, good housekeeping rules would be to delete it. I left it for you guys can check the first bundle adjustment I did, and the update will be doing now that we finished tagging our GCPs. We're not going to do RTK. We're going to go for a full AT unconstrained, because we're going to rely on the position of our GCPs. Sensor calibration unconstrained, and the ground reference, of course, is going to be ground control points. No image filtering, so we're going to process that. And once we did that, well, let's take a look at the report. And not bad. Average XY error 0.027, RMS Z 0.25. So really nice. Average projection, half pixel. We can actually see now the image type point assessment, the average projection and standard deviation are pretty good, especially for drone data. And we can go all the way down to our report to actually see a detailed GCP report. Now, this is this is what we want to see, right? Rescuing a project that otherwise they thought it was RTK. It's not RTK corrected, but hey, guess what? We do have some GCPs around there that we could use. Now, what was the other alternative I was thinking about? Well, it's in a well-populated area. Again, go to the county files and look for some publicly available lidar. I've gone through several websites, tools, and they provide sometimes a DSM at certain resolutions. Even better, you might get a point cloud of this specific area and then import it. And then you can create your own GCPs. We covered this in our previous webinar. If you missed it, go back to that webinar and I'll show exactly how to create some GCPs from your reference ortho, which is your intensity image, and your DEM coming from your lidar. And again, we have several features on this particular area where you can extract some GCPs and even make this even better. But of course, we used what they provided us, and that was a quick way of just providing a solution for data that was otherwise not meeting the accuracy requirement that they needed. Could we have processed this unconstrained without GCPs? Absolutely. I want to make sure to highlight that. Even if I didn't have GCPs, I could have processed this unconstrained, but of course, it wasn't going to meet the accuracy requirement that they needed. So this is a quick overview of how we can do that. And now let's do a quick check, right? Now that we've done this process, let's actually uncheck the actual AT. And let's go back to the completed project to see our deliverable. So let's go here to our flight. And what we're going to do really quick is review the DSM, right? So we're going to remove the images here. We're going to remove our mosaic, which looks great. And that DSM looks really, really good. How accurate it is against the GCPs and checkpoints it provided. Well, let's take a look at that. I mentioned we go to Processes, DM Inspection, and we ensure, of course, that we're comparing the DSM that we need to compare against the GCP file we need to compare, and then we process it. And we get our statistics. So our bias error, standard deviation, RMS error, and maximum error. If this falls within the standards of what they need, we can proceed. If not, we can incorporate a couple more GCPs, right? Again, these GCPs weren't the best GCPs. Again, they were on the corners, but they weren't really meant for this particular project. So sometimes, you have to make the best of what you have. Otherwise, I would have probably preferred to go with finding some lidar data, some external DEMs, and other reference orthos, and then try to do that. But again, for the extent of the project and the AOI, these GCPs were enough. The absolute accuracy that we needed for this project was met. So this was all in all a good rescue, right? And just kind of proving how flexible Correlator can be with data that otherwise, just you'd be like, well, no, let's toss it and go refly. Which, let me add to that, they did refly with RTK enabled this time, and we got the data again. So we were able to reprocess that as RTK, true RTK data. So that's a quick wrap on it. Again, just showing you a little bit of the mosaics and what we did here with the process. But this is a very nice project. I always like to highlight the fact that you have so many tools within Correlator that you can do some mosaic editing. That's something that I always like to highlight. The final product always needs to be a QA/QC process, as we established, and part of that is doing your seamline edits. I won't stress the fact the OrthoPatch tool is an amazing tool. Of course, picking the best part of orthos and, as the name states, patching it into that mosaic, doing a very nice color balance of everything. So if we do just a quick recap, let's take a look at the reports that we've got here. This is a particular report using GCPs, as we stated, so we have our detailed error for those GCPs. We do have a secondary report, and they were used as checkpoints. So this is the secondary flight I mentioned. These were done, again, the same area, but with a flight that was true RTK with the same points. I actually used the same points and brought them as checks. So you can see there the detail error for the checks, a couple high ones here for Y. But again, I'm using checkpoints weren't really meant for this project, but again, they saved the day when we had to do that first project that was not RTK. Nonetheless, you can see I have now both solutions, one that was done as true RTK, same area flow, and you can see, and in this report you can actually see that it's RTK PPK assisted. And we got, of course, let's go to the top, excellent quality assessment, and incorporated those checkpoints. So you get the best of both worlds. If you validate that this is actually RTK-PK data, you import them as checks and you complete your checks and your quality assessment. And if it's not, then you always can default back to ground control points and use your ground control points to, again, tie your solution, improve your solution to a better absolute accuracy. If you guys have any questions, we have several channels where you guys can go through. Most important is our support portal. Please don't feel shy to reach out to us via our support portal, create a ticket. For all you guys asking questions, we'll be more than happy to answer those. So you'll receive an email directly from us. And again, that's really a wrap for today. And thank you very much, guys, for your time. We appreciate it. Bye.